Okay, here's the recording in progress. And I'll share the screen here. All right, so I'm a little bit ahead. I'm going to give you the quiz. I've already started 4.6, and I'll do very little of 4.6. I still have next time to do some of 4.6. Okay. And then we're aiming for the next exam, Friday, November the 5th, it looks like. Okay. So I'll give you the quiz, and I was going to end a little bit early today to give you time to start working on the quiz. All right. And so I won't have much of a lecture at all today. Do a few problems involving graphs of a tangent function and the other trig functions. But let me give you the quiz right now. Okay. So if you wish, it's being recorded, so you can always watch the video. But if you want to take a picture on your cell phone or do a screenshot of the quiz, okay, here we go. Okay, number one, to determine the height of a tree, a person stands 40 feet from the tree and finds the angle of elevation. So you're looking up like that. Angle of elevation is 37 degrees. Find the height of the tree to the nearest whole number. Okay, so we've done problems like that. Look back in your notes as to how we do a problem of that type. Okay. And the nice thing about trig is you can measure something without literally measuring it, but by using trig. You want the height of a tree. Well, I don't feel like climbing up the tree. I'm kind of scared of heights, right? Okay, but you can walk along the ground. I don't mind measuring along the ground, and then I can find the angle, right? The angle that I'm looking up at is 37 degrees. So use that information of height, find the height of the tree. 2 and 3 involve reference angles. It's a little bit clumsy. Find the reference angle for an angle of 1,013 degrees. So if you have 1013 degrees, that's not very familiar. So you want to find angles that are coterminal with it. So my suggestion is to subtract multiples of 360. So in other words, take off 360, right? Take off another 360 or as many times as you need to until you get an angle that you recognize, so to speak. Okay, something between 0 and 360. Then figure out what quadrant you're in. And then based on that information, go from there. Okay, I don't want just an answer. So if you just give me an answer, you just put down something like 27 degrees, which by the way is not the answer, but if that happened to be the right answer and that's all I see, I don't give you credit for that. I need to see how you came up with that, right? So 1013, take off multiples of 360 until you get something you recognize, then figure out what quadrant you're in. Likewise for 3, give the reference angle. This is in radians, and they give me a negative angle, negative 23 over 5 pi. Right, so my suggestion there is to add multiples of 2 pi. You might have to get a common denominator. So add multiples of 2 pi until you get something that you quote unquote recognize and don't have that weird negative either. So add 2 pi, add another 2 pi, and I'll go ahead and tell you 2 pi is what, 10 pi over 5, right? So I'm kind of giving you too much of a hint already. So you add multiples of 2 pi in the form of 10 pi over 5 until you get something nice that you recognize, figure out what quadrant you're in, and go from there. Finally, 4, a full-fledged graph of one period. Okay, -2 sine 3 parentheses x minus pi over 6 plus 1. Include a discussion of amplitude, period, horizontal, and vertical shifts, and the midline. It's all here. This controls amplitude. This controls period, horizontal shift, vertical shift. So again, I'm kind of giving you too much of a hint, but that's okay. I'm sure you don't mind. And label important points. So give the coordinates if you're starting at any points, and also the points that are 1/4 of the way, halfway, 3/4 of the way, and the full way where you start and you end. Okay, so some hints. You know the formula for amplitude. You know the formula for period, horizontal shift, vertical shift. So you figure out the range. The normal sine function goes from -1 to 1. And then the range will change based on this and also this, right? Figure out how you're going to go for one period. One period, you would start from 0 to whatever, but then there's a shift. Okay, and furthermore, you've got a sine. So sine normally, look at the pattern, sine normally starts at midline, maximum, midline, minimum, midline, but there's a negative. So a negative, that's going to get reversed. right? So for negative, it's going to start midline, minimum, midline, maximum, midline. Okay, so I'm giving you way too many hints in my opinion. So you take it from there. All right, so there's the quiz. Due at 11:59 p.m. Open everything, but you have to show me all your work and work it out the way that we did it in class, so to speak. Okay, so I don't mind if you talk to other people, get some help, look it up on the internet. That's fine, but the way you work it out has to be the way we did it in class. And of course, show all your work for all these things. Okay, so that's the quiz. And if you have any questions about the quiz, you can ask me at the end. And the end today is going to be fairly quick, since I don't plan to have too much of a lecture to give you more time to work on the quiz. Okay, so getting back to where we were last time. Let's see. Let me go back over this one. Again, 4.6, number 15. They tell me secant of t is 3. I'm in quadrant 4. So if the secant is 3, the reciprocal cosine is 1/3. Just flip it. Okay, this is all students take calculus. All three trig functions, sine, cosine, tangent, are positive. Only the sine is positive, only tangent, only cosine. All right, so use cosine squared t plus sine squared t is 1. 1/3 squared plus sine squared t is 1. 1/3 squared is 1/9. Subtract 1/9. 9/9 minus 1/9 is 8/9. Take the square root of both sides. I'm in quadrant 4, so the sign of the sine, the SIGN of the SINE is negative. So I want negative square root of 8/9. Square root of 9 is 3. 8 is 4 times 2. So sine of t is negative 2 radical 2 over 3. And yeah, once you have that, you got everything else. So cosecant, flip it. Negative 3 over 2 radical 2. And tangent is sine over cosine. So negative 2 radical 2 over 3 divided by 1/3. And you should know the trick that 3's just cancel out. So negative 2 radical 2 is a tangent of t. Flip it. Cotangent of t is negative 1 over 2 radical 2. All right, quick review of the tangent, cotangent, secant, cosecant graphs. Okay, so you might recall the graph of the sine. Sine, as we said, starts midline, maximum, midline, minimum, midline. But if there was a negative coefficient, then it reverses, right? That's a hint for the quiz, additional hint. Cosine, maximum, midline, in this case it's 0, minimum, midline, maximum. Okay, tangent was sine over cosine. So whenever the cosine is 0, the tangent is undefined. So undefined at pi over 2, 3 pi over 2, negative pi over 2, negative 3 pi over 2. Whenever the sine of x is 0, so is the tangent. So tangent is 0 at 0, pi, negative pi, and so on. Okay. Sine and cosine are equal at pi over 4. That means the ratio is 1. They're opposites at negative pi over 4. So if you connect them, you get a graph right here. So the period is pi. So here's one period of the tangent function, from negative pi over 2 to pi over 2. And then you just copy and paste, copy and paste. There's another one here and some more over here and so on. Okay, cotangent, cosine over sine. So whenever the sine is 0, cotangent is undefined. That's at 0, pi, 2 pi. Whenever the cosine is 0, so is the cotangent, pi over 2, 3 pi over 2. If cosine and sine are equal, like pi over 4, the value of the function is 1. If cosine and sine are opposite, like 3 pi over 4, negative 1. So it goes like this. Okay, so the period of the cotangent and the tangent is pi. Okay, all the other 4 trig functions have periods 2 pi, sine, cosine, and the reciprocals. But for tangent and cotangent, period is pi. Okay. Notice the tangent is increasing, cotangent is decreasing. Okay. Now, since you're allowed a cheat sheet you don't have to memorize this, but if we were meeting face to face and you needed some memory trick, I had a memory trick that for the tangent, okay, if you are on a beach and you want to get a tan, you're looking up. So you're looking up, so increasing up. And a cot, if you're sitting down or if you're lying down on a cot, right, you're lying down, so to speak, so you're going down. So I think of tan, looking up, so tan is increasing. If you're on a cot, a bed, a cot, you're lying down, so that function is decreasing. Okay, so a tan, you get a tan, you're looking up. Okay, if you're on a cot, you're lying down. So anyway, that's my memory trick. Okay, and a review of the reciprocal functions. So cosecant is a reciprocal of the sine. So sine looks like this, one period. And then I just use the rules for reciprocals. So 0 has no reciprocal, vertical asymptote, vertical asymptote, vertical asymptote. Graphs match at 1 and -1. And then do the increasing, decreasing game. One goes down, the other goes up. Okay, this goes down, this goes up. This goes down, this goes up. This goes up, this goes down. This goes up from right to left, this goes down. And same thing for secant, reciprocal of the cosine. So here's the cosine function. The cosine is 0 at pi over 2, 3 pi over 2. Therefore, the reciprocal is undefined. Vertical asymptote. Graphs match at 1 and -1. And then increasing, decreasing. Here we decrease. Therefore, this increases. Okay, let's see, starting from here, right? Going this direction, increase, decrease, increase, decrease, right? Going, starting from here, if I go right to left, decrease, therefore increase. Okay, so that's secant. All right, I was just going to do a few problems left from the section and then stop. So I won't finish the entire section, but I'll do some of them. Like 17, how do you graph 3 tan x and -2 secant x, number 19, and stuff like that. And then I'll do some of these equations here also. Okay, so I won't do them all, but I'll do some. You need to have enough time to work on the quiz. 3 tangent x. That's a vertical stretch. Okay. By the way, we don't call this amplitude. It is a multiplication factor, but if you want to think of the definition of amplitude as maximum minus minimum divided by 2, well, the tangent has no maximum and has no minimum, so that doesn't apply. However, we still will multiply it by 3. So 0, 0. Okay, the original tangent function I have in red. Okay, right here, the y value is 1. Multiplied by 3, it's up to 3. So the green graph, 3 tan x, goes like so. Then over here, when I back up, this is negative pi over 4. The y value is -1. Multiplied by 3, I'm at -3. So it's the vertical stretch again. So above the x-axis, it shoots up higher. Below the x-axis, it goes down lower. It goes to negative infinity faster also, so to speak. So that's 3 tan x. Okay, 19, -2 secant x, -2 secant x. Okay, so the regular secant I have in red. So if you can kind of ignore all this, the regular secant graph is in red. Maybe we'll just go piecewise here. Okay, now -2. Right here, the function value is 1. If I multiply by -2, it's -2, so it shoots down. Okay. Right here, the function value is -1. Multiply that by -2, it's +2, and it shoots up. And then over here, the regular secant function, here the function value is 1. Multiply that by -2, -2, and it goes like so. Okay, so again, the multiplication factor, it kind of reflects across the x-axis, but in this case, it does more multiply, it doubles this, the function values also. So this part goes down, this part goes up, this part goes up, this part goes down, and so on. And the maximum and minimum aren't -1 and 1, but because of this, it's now -2 and +2. Okay. All right. Yeah, somebody had a question? Okay. Okay, 25 changes the period. Okay, remember how for cosine and sine, the period was 2 pi over b? And by the way, that's a hint for the quiz also for question 4. Well, the period for the tangent is pi. So rather than 2 pi over b, the period is pi over b. Here we are, period is pi over b for the tangent and cotangent. If you want to put that in your formula sheet, you may. Period is just pi over b. So tangent pi over 2x, the b is pi over 2. So period is pi divided by pi over 2. If you divide by a fraction, you multiply by the reciprocal, pi times 2 over pi. Pi's cancel out. I just have 2. That's nice. So by having that pi coefficient, that's how you can get rid of all the pi stuff. So you get stuff that doesn't have pi. You just have 1, 2, 3, 4, and so on. Okay, so
when it comes to like graphing tangent and stuff, and you ask for like a period, can you do a period on any part of the graph, or are you specifically looking for something like between two asymptotes?
For the tangent, you should straddle 0. Okay, so you shouldn't pick one that way out by 7 pi or 9 pi or whatever.
Oh yeah, I know, but like, what if like usually I graph tangent from like 0 to it's the end of its period? Would that be okay, or?
No, not for tangent. You definitely don't want to start at 0. Okay, for the tangent, what you want to do is this, and that's a good point. I was getting to that. But for tangent, you don't want to start at 0 because one period goes from -pi/2 to pi/2. So in other words, you cut it in half. The period is pi, but you kind of want to straddle the y-axis, so you go halfway each. So the period is pi, so you go half a pi in both directions. Okay, so in this particular case, which sort of leads to your point, I believe, the period is 2. So starting at 0, I go 1 each direction, 1 to the left and 1 to the right to get 1 period. That is far superior in general than to go from 0 to 2, let's say, because then you have a branch like that and a branch like that, which looks kind of unnatural. Okay, but here it's all connected. Okay, so the period is 2. And so for tangent, the period is pi, which is going from -pi/2 to pi/2, which means I start at 0, I go halfway here, halfway here. So in this case, now that I know the period is 2 pi over b, I go 1 each direction. So here's -1, here's +1. Okay. The rest of the graph is the same. So halfway between 0 and 1 is a half. I go up to 1. Halfway between -1 and 0 is -0.5. I go down -1. And then I draw the same general graph, like so. So there's a tangent of pi/2x. Okay. All right, I was going to show you a couple of problems for equations, and I'll stop. So I'll be done in a few minutes, unless anybody has any questions. Then I'll take the questions, or if you have a question about the quiz, you can ask that also. So let's see, how about 29 and 33 I was going to do. Tan t plus 1 equals 0. Find all values of t on the interval 0 to 2 pi inclusive. That satisfies the given equation. And 33, absolute value of tan t is equal to 1. Okay, so let me show you that. Tangent of t plus 1 equals 0. That means tangent of t is -1. Okay, tangent is sine over cosine. If I get -1, that means the sine and the cosine are opposites. Okay, well, that's in quadrants 2 and 4. If I think back to this chart, the tangent is negative in quadrants 2 and 4 because tangent is positive in quadrants 1 and 3. So what angles have a reference angle of 45 degrees in quadrant 2 and 4? Well, that's 3 pi over 4 and 7 pi over 4. Okay, so the two angles that I want between 0 and 2 pi are 3 pi over 4 and 7 pi over 4. For 33, it says absolute value of tangent t equals 1. It's almost like 29. Think back to when we were doing absolute value, right? Cover it up. Sometimes I would say, if you don't like looking at something, don't look at it, just kind of cover it up. So I got absolute value, blah, 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 equals 1, which means behind my finger can be a 1, or it could be a -1. So there it is. Tangent of t is -1, just like over here. Or tangent of t is 1, which means sine and cosine are opposite, just like 29, or they're equal. So I have all 4 angles, one in each quadrant, that have a reference angle of 45 degrees. So that's here, 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 and here. So the t's are pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. And that's how 33 works. All right, folks, I was going to stop there, let you ask questions, and if not, I was going to give you the rest of the time to start working on the quiz. Let me stop the share and see if I can check the chat. Okay, so anybody who wants to ask a question, you may. Otherwise, we're done for the day and let you go on the quiz. Okay, any questions, please? Okay, question 4.523. Let me see what that's about. (4.523). Okay, so that looks like a multiple choice one here. Match the equation with the graph. Checking if we do that one. Yeah. All right, so let's see. A, amplitude is 2. So it's got to be either 3 or 4, right? So 2 sine x minus pi over 2. So I shift pi over 2 to the right and start at 0. So that seems over here. Okay, so A seems to be 4, which automatically means this one has to be 3. And let's check. Shift the cosine pi over 2 to the right, starts at the maximum. Yes, that does it. And both of these have an amplitude of 1/2, so it's got to be between one of these two. And there's a shift of pi over 2 to the left. Okay, pi over 2 to the left, sine would begin at 0, so that seems to be this one. So this should be I. And then by elimination, the only thing left should be this one, I. Let's double check. If I shift pi over 2 to the left, we start at the maximum, yes. Okay, so A should be 4, B should be I, C should be I, and D should be I, looks like. Okay. All right, and let me check the chat again. All right, any other questions, please? All right, that'll do it. So have a good weekend, everybody. Quiz is due at 11:59, open everything, but do it the way that we talked about in class. All right, that'll do it for today, folks. Have a good day and a good weekend.
Thank
Bye.
you.
Thank you. Bye.
Thank you.